timeout, and if the data has been missing for the duration of the timeout, then we reset the master, the control panel, to a default state. And the problem was that I did not initialize the initial time. It was set to 0. So when the counter wrapped around, it actually generated a false timeout. And the explanation is actually farther down in this Stack Overflow post here about using time before and time after in Linux kernel. And it's used with the Jiffy's counter. And there's a very good explanation here, which basically explains what I've been experiencing. So there is a fundamental assumption that timeout was initially calculated as Jiffy's plus some offset at some prior recent point in time. So the time, when you set this timeout, when you calculate the timeout, it has to be back in time, but in a but not farther back in time than half of the counter of the size of this counter variable. If it's more than that, then it's going to result in an error. So it's very important to make sure that this counter is updated often. Even so, if it maybe every second, I should be actually updating the counter to make sure that it never gets too old and causing this timeout to misfire. So if you're trying to measure times longer than this, then things break down and you'll get wrong answer. So yeah, this is something that I need to review in my code, just to make sure that I'm not using this timeout in the wrong way, and that I'm initializing the timeouts often enough, so that the code that checks for the timeout never executes too far into the future when the timeout has long past expired. All right.